Alright guys, welcome to your level 3 8.7a notes for volumes of a cone. Today we're going to talk about how to find the volume of a cone. So if you will get this page out, make sure you have it and you're going to write down as we go through these notes, and then you will paste it into page 22 of your journal. Talking about volume of a cone, we kind of talked about that on level 2, how the volume of a cone is 1/3 that of a cylinder. Okay, the cylinder formula is base times height, and that base is the area of the base, which is a circle. And on a cone, if we look at the bottom, it is also a circle. We also have the height that cuts through down to the middle, down to that center point of that base, and it creates that 90-degree angle. So that's what we get, where we get that height from. What we'll plug in for that base is, because it is a circle, that's where this pi r squared comes from. So the overall general formula is volume equals 1/3 base times height, which is what you're going to see in your notes or on any formula charts that we have. Especially when you flip to the back of your journal, you'll see that there's that 1/3 base times height. So remember, it's crucial that we know what big B represents, and so we know what we can plug in. In this case, since our base is a circle, instead of big B, we're going to type in pi r squared. Now also remember, when it comes to pi, if they do not specify, use pi. But if they do specify to use 3.14, make sure to go ahead and use 3.14 for pi. Alright, so enough talking, let's get straight to our first example. Alright, so this very first example, they gave us our cone. We see that we have a height of 6 meters and we have a diameter of 4 meters. Alright, our volume for our formula is going to be 1/3 base times height. Okay, not just base, but remember, big B represents area of the base. So make sure that we remember that big B is not base, it's area of the base. We're going to go ahead and fill in that area of the base, and since we do have a base of a circle, that area formula is going to be pi r squared times that height. Okay, going ahead and substituting in what we know. Alright, it doesn't specify to use 3.14, so we're just going to use pi on this example. Now we have to look for our radius. Now remember, they gave us a diameter. Okay, a diameter goes from edge to edge of that base of that circle. A radius goes from the center point to the edge. Well, the radius is also half the diameter, so if this diameter is 4 meters, then our radius is going to be 2 meters. So we're going to put that times, and we're going to square it, and our height is 6. So as we go through, and we're going to kind of go through and simplify. When we simplify, we're just going to kind of take the things that we know that we can do kind of up front and easier. Alright, so as we go through and simplify, we're going to keep this 1/3, we're going to keep this pi, we're going to simplify this part. 2 squared is 4. So we're going to have 4 times 6. Okay, I'm going to go ahead and simplify it just a little bit further. So I have 1/3 pi, 6 times 4 is 24. This is much easier to see than all of this up here. Now if I want to go through and kind of simplify it more, I could do 1/3 times 24. 1/3 of 24 is 8. So I'm going to kind of bring this back up here. So 1/3 times 24 is 8. So remember, we talked about on our level 3 of cylinders, we can answer in terms of pi. So I've gone through and I've put my answer in terms of pi here. So my answer for this cone is 8 pi in terms of pi. Now, if it doesn't specify that and it wants us to go ahead and round, in this case we're going to go to the nearest hundredth. Okay, so remember, that's 2 places after the decimal. We're going to go ahead and do our 8 times our pi. So going into our calculator, 8 times second and that caret key, that's going to give us 25.1327. Since we're going to hundredth, we're going to look at 3, 2 determines, we're going to keep it there. So our answer is going to be 25.13 meters cubed. Looking at our next example, on this one, we've been given our volume, alright, and our radius, but we have not been given our height. So we're going to go through and we're going to look for our height as we go through and solve for this one. So once again, our volume formula for a cone is going to be volume equals 1/3 area of the base times the height. Going through and, oops, don't want to simplify just yet. We want to go ahead and kind of plug in what we know for that big B. We know that big B is that area of the base. Base is a circle. So we're going to plug in that pi r squared for base times the height. Now we can simplify, or sorry, there you go again. Now we can substitute. We're going to substitute in what we know. Okay, we know 1/3. We know that our volume is 956 feet cubed. We have 1/3. We're going to go ahead and use 3.14 on this one just to kind of give us an example with 3.14. Okay, we're going to have our radius. We know our radius is 9. They gave us our radius, not the diameter. Okay, so we have 9 squared times our height. We still don't know what that height is, so that's what we're solving for. Okay, we're going to go ahead and just kind of simplify a little bit. So I'm going to have 956 equals 1/3 times 3.14. 9 squared is 81 times our height. So we have this very large piece here. What we can go ahead and do is just go through and multiply 1/3 times 3.14 times 81. If I multiply those across, I'm going to have 956 equals, we're going to have 84.78 H. Remember, all I did to get this was take 1/3 times 3.14 times 81, and I got this. Now, if you look here, going back to our equations piece, this is a simple one-step equation. To get our variable by ourselves, we're going to divide by our coefficient, 84.78. These cancel, leaving me with H equals 11.3 feet. Because we're talking about the measurement, we have just single feet. We're not squared or cubed. So this right here is our height. Okay, our last example. This time we haven't been given a picture. So remember, if we're given a word problem, we want to always make sure that we are going through and drawing a picture. So we have a cloth pastry bag is shaped like a cone. So we know a cone has a circular base and comes to a point. We have a radius of 1.5 inches. So it goes from the center to the edge, and our radius is 1.5. This is the height. So we know the height goes from that center all the way to the tip of the cone is 8.5 inches. We want to know the volume of the cone to the nearest tenth, and we're going to use 3.14. Okay, so our formula for volume of a cone is 1/3 area of the base times the height. Going ahead and simplifying that a little bit more, we know that area of the base, since it's a circle, is going to be pi r squared. Okay, now we're going to substitute in our information. 1/3. This tells us to use 3.14, so instead of pi, I'm going to plug in 3.14. Our radius is 1.5, so I'm going to have 1.5 squared. And then we know our height is 8.5. Now remember, you can, if it's easier for you, just go ahead and plug all this in, and you'll go ahead and have your volume. I'm just going to simplify it just another step. So I'm going to go 1/3. I'm going to go ahead and I know that 1.5 squared is 2.25. So I have 3.14 times 2.25 times 8.5. Okay, I'm going to go ahead and do these three multiplications here. Remember, it doesn't matter. You can do them all at one time if you want. So 3.14 times 2.25 times 8.5 gives me 60.0525. So I have 1/3 times 60.0525. And then since I am multiplying 1/3, it's the same thing as dividing by 3. We get a volume, remember we're going to the nearest tenth, a volume of 20 cubic inches. Alright guys, that's the end of our level 3 video for cones. If you're stuck or have any questions over any of this, please raise your hand. I'll be right there to help you. If not, go ahead and glue this into your journal, and you can go ahead and start your practice. Make sure you submit your answers before you do your quiz.